Hello friends, in this lecture we are going to look at deep learning. We are not going to discuss deep learning in detail, but since we are going towards deep learning models, this particular set of lectures will introduce deep learning and different elements of the deep learning so that when we will discuss about graph neural networks, you have idea about those terminologies as well as you can perform some of the tasks in an easy manner. So far, in a node embedding or edge embeddings, we discussed about encoder decoders and shallow embedding. However, there are complex encoder models like graph neural networks, which will be used in a network biology, are actually deep learning models on a graph data, where we are interested in learning encoder function fn for u as a my node, which is a nonlinear transformation of graph structure or node in general. And that's the reason we need to learn different components of deep learnings. Deep learnings is a quite exciting field for last 1 decade. However, it existed in a different forms earlier also. Particularly different components of deep learning like neural networks. And advent of big data and other computational facilities and the technological as well as algorithmic advances, deep learning or in general neural network learning is revived, and there are so many novel deep learning techniques that have been introduced to us in last 2 decades. Many speech imaging text data, we have many state of algorithms which provides very great performance, and we are using deep learning nowadays for several tasks like Google Translation is one of the example, and hence I think that deep learning is kind of around us, and we are going to give an introduction, a bird's eye view of deep learning and different components so that we can actually introduce you to graph neural networks in coming lectures. So we have discussed node features, and there we saw that shallow embedding encodes the structural information, typically linear. Why do we want to go for a deep learning or graph neural network based approaches? So main advantages of GNN is it integrates structural information plus it will also integrate node features or edge feature in the learning process. Remember that so far we have looked at only node as an entity and its surrounding neighboring entities as features of node. However, we have not characterized node's feature alone. In many applications, the node features are important. For example, gene expression of proteins or text data in social networks. And I'll give you two simple examples. Here, this example is example of molecular graph. Here, I can actually convert this molecule in a graph by assuming each atom as a node, and if there is a bond between them as an edge, and I can have an equivalent graph. However, you can realize here that each of this different color indicates different atom, and each of these atom has its own characteristic. For example, see carbon atom has there are a lot of different characteristics as a atomic number, charge, etc. Hybridization type. Similarly, N has a different partial charge, hybridization type, atom type. Similarly, O has that. Correct? Now, this information have not been used during the node embedding that we have seen so far during the course. Let's look at another example, social media example. Here, this particular node can be distinct, or they have a certain based on certain characteristics, or each node has a certain characteristic. For example, age, gender, geographical location, text messages they are exchanging with each other, their interests in a different kind of hobbies, etc., provides certain features to that particular node or that individual. And we have never, during the node embedding, discussed about how to incorporate those node features. Hence, when we look at whatever we have learned so far, node embedding, they fail to actually provide a solution for this kind of node features data. While graph neural networks allows us to actually not only do what node embedding can do, but also provide us with a ability to also embed this kind of node features during the learning processes, or even age features during the learning processes. And that's why we would like to learn graph neural networks. And before we go towards graph neural networks, what we want to do is we want to have some idea about what is a deep learning in general. Of course, as I told you, this is not a course in a deep learning. For more knowledge and learning about deep learning, you have to go through a formal course, but it is an introduction which will help you to understand some of the graph neural network models which we are going to discuss in the next couple of lectures. So, in deep learning models, they are typically feed-forward neural network models, are kind of basic deep learning models. And here we have a typical neural network has an input, output, and hidden layers. So same neural network structure also carry forward to the feed-forward neural networks, which are deep learning model, or sometimes it's called deep feed-forward neural networks. Deep in a sense of having a more than 3 layers or hidden layers, to be more specific. Each neural network has an input layer, output layer, and hidden layer. However, deep neural network has a more than typically 3 hidden layers, then it becomes a deep neural network. And similar to neural networks, the objective of deep learning model is to find a mapping function fx or approximate some ideal model, which is the underlying ideal model, which is y star x, using some function f of x given theta, where theta are the parameters of the model. An objective of training is to learn parameters theta to approximate the underlying ideal model f star x. So what we want here is f of x theta should be approximating f of x. This is what is the objective of learning. Now let's look at the simple Perceptron model, which has been introduced as a basic model of neural network, and then we will see how we can build a more complex deep learning models, neural network feed forward neural network models using the same kind of ideas. In Perceptron model, it is a binary classifier with which means it's a supervised learning approach, where input is a set of xi. There can be n inputs. Here we have 4 inputs, n is equal to 4. In this example, if you can see, 4. So we have x1, x2, x3, x4. Neuron is basically weighted combination of inputs, which is I have shown here as some kind of node. It will do 2 tasks. It will collect weighted combination of input, including there is a term typically called bias, and these are called weights. So it will combine both, and it will apply a thresholding function alpha to it to produce output y. So depending on the thresholding function and threshold, we will have either output equal to 0 and 1, and typically the objective of learning process is to find these weights beta b using the data available to us, which will be x1, x2, x3, x4 and the corresponding label. Let's take a simple example here of binary classification, where I have an email and I would like to classify the email as being a spam or not being a spam. And I have provided 4 features: number of words x1 in the email, average word length x2, number of uppercase letters x3, and number of numericals x4. And these are those statistics for email 1 and email 2. So what I am going to do is I will take this for value. I have provided you already the weights. Okay. So you can multiply with this weight, and alpha is a simple linear model. So alpha will directly produce, take this value and gives the answer. So here the thresholding is greater than 40 and less than 40. So for the email 1 it is 13.7, email 2 is the 15.5. So email 1 is 0, email 2 is a 1. If 0 indicate spam email and not spam equal to 1, then email 2 is not spam, email 1 is spam. So depending on how you define your class and the number, it can be spam or not spam. Here I have indicated 0 being spam and 1 being not spam. So you can see simple Perceptron model provides you the detailed classifier for email is being spam or not being spam.